So now I have one for you to try. So if you want, you can pause this, try to go through some of these different parts of the question and see how you do, or you can just follow along with me as I go through. So it says in 2010, Dr. Bob decided to gather research on the type of disorders that present among his patients. His data collection resulted in the following breakdown of patients by disorder. So 54.9% schizophrenia, 21.1% major depression, 7.9% obsessive compulsive disorder, 4.5% anxiety disorder, 2.9% personality disorder, and 8.8% other. Information was collected from a random sample of 300 patients in 2018 to determine whether or not the data has changed significantly. The sample data is given in the table below. At the alpha equals 0.01 level of significance, test the claim that the disorder breakdown of patients at Dr. Bob's hospital has not changed significantly since 2010. So it says which would be correct hypotheses for this test. So remember the null always says that the distribution is the same, and then the alternative says that it differs. So if I look at the four options I have, I can cross out a couple of these, right? I can cross out the first one that talks about proportions, and the last one's talking about means, right, which we're not doing here. So that leaves me with the two middle ones. So we want the null should say that it has stayed the same. So if you look at the second option, it says the breakdown of patients by disorder has changed significantly since 2010. We don't want that. That should actually be what our alternative looks like. So it doesn't look like it's this one, so we're hoping that it's our last choice where it says the breakdown of patients by disorder has not changed significantly since 2010, right? So the given distribution still fits. And the alternative is the breakdown of patients by disorder has changed significantly since 2010, which is the given distribution no longer fits. So that is the correct one. That's the one that we would choose. All right. So then it says type of disorder per patient in the sample, right? So it says we sampled a total of 300, right, which is important because that's what my N is. So this is what was observed, right? So we need to figure out what's expected, and we still have to calculate this, right, no matter sort of what we do. So we need to take the expected, right, so expected would be the 300 times the corresponding probabilities. So for schizophrenia, right, they said 54.9%, so we want 0.549. And I'll calculate this once I write everything down. My major depression, right? So again, it should always be 300 times the probability of that category. So major depression was 21.1, so 0.211. Obsessive compulsive disorder was 7.9, so 0.079. Anxiety disorder was, it was 4.5. So 0.045, and personality disorder, that was the 2.9. So 300 times 0.029. And my last one, right, which is just the other category, which was 8.8, so 0.088. Okay, so we'll type these in the calculator to see what we get. So I have 300 times 0.549. So 164.7. And we'll keep all the decimals. We won't round till the end. So 300 times 0.211. So 63.3. I have 300 times 0.079. So 23.7. 300 times 0.045, so 13.5, 300 times 0.029, so 8.7, and then my last category, right, 300 times 0.088. All right, so 26.4. Perfect. Okay. So, oops. There we go. Sorry about that. Okay, so this is my expected, right? So O is going to be observed, which will be in L1, and expected will be in L2. So I'm ready to type this in my calculator. So we'll hit my stat button. We'll go over to edit and hit enter. I have some data in before, so we'll just clear this out quick. Clear it. 1. So now I can type in my information. So I have more categories in this one than we did in the last example. So no matter the case, we just enter them sort of how it's given, and then we'll go back and enter what we would expect. So here's my observed, my expected, with all of the decimal places in as well. 63.3, 23.7, 13.5, 8.7, and 26.4. Okay. All right, so now we can go to our stat button over to tests. I'm going to arrow up to goodness of fit test. Again, L1, L2 should be the same. Now my degrees of freedom, remember, are the number of categories minus 1. So I have 1, 2, 3, 4, 5, 6 categories. So 6 minus 1, I should have degrees of freedom of 5. And I'll calculate that. So my test statistic, right, chi-squared, is 18.106. My p-value, 0.0028, right? So my alpha level, right, is 0.01. So 0.0021 compared to 0.01, alpha is larger, so we are going to reject the null, right? And so my next little part says, which of the following results, right? We're going to reject the null. And so we would say there is enough evidence to suggest the breakdown of patients by disorder has changed significantly since 2010, right? So we're concluding that basically the distribution does differ. Okay, so our last little bit of example, it says, how do you find the degrees of freedom for a goodness of fit test? It says, so example 2, you intend to conduct a goodness of fit test for a multinomial distribution with 3 categories. You collect data from 81 subjects. What are the degrees of freedom for the chi-squared distribution for this test? So remember, degrees of freedom for a goodness of fit test is k minus 1, where k is the number of categories. So as long as you know the number of categories, you can find the degrees of freedom quite easily. So 3 minus 1, my degrees of freedom for this test would be 2. The last thing I would just want to talk about, we didn't go through and do an example like this, but sometimes, as we saw in our last examples, they had seen, right, we saw specific probabilities or percentages for each category, right? Schizophrenia, major depression, they had all these broken down. Sometimes, the way the question is worded, you could have a uniform distribution, or they say something, right? So uniform distribution means all of the categories have the same percentages, right? So the percentage we should always be adding up to, right, is 100%. So if you have 4 categories, right, so 4 categories, then you would take your 100%, right, divided by the 4 categories. And so each category would have 25%. If you had 3 categories, you take the 100% divided by 3, and you get sort of like 33.33%. There's some rounding error there. But if it's talking about sort of a uniform distribution and it doesn't really give you percentages, you take your 100% and divide it by the number of categories, and you use that to just sort of to help you determine what the expected value